So previously we looked at multiplying polynomials. Basically it was a monomial times a binomial, one guy times two guys, or a binomial times a binomial, trinomial times trinomial. Pretty straightforward, either using distribution or the box method in order to get the final expression in a simple standard form. We're going to continue looking at multiplying polynomials today because there is actually a couple different things that could occur. For instance, we have binomials that have the same letter and variables in the same order, but different middle signs. These have a specific name to them. These are known as conjugates. Basically, they are opposites. Even though they may look the same, they have opposite signs. And what happens is the middle terms are going to cancel each other out. Another instance that occurs is, let's say I take a binomial and I use an exponent on it. Basically, it's not what's inside each individual thing raised to the power of 2. It is following the same rules as before. Anytime I have an exponent, that tells me how many times I am multiplying that particular item. So you must write out what is inside the parentheses, the number of times indicated by the exponent, and then complete the operation. So simplify the following. Number 1, we have 2x minus 3y times 4x plus 5y. What we have here is either using box method or distribution. I'll show you both here. Distribution, it's going to be the same as before. I'm going to take the 2x and multiply it times both items inside parentheses. So 2x times 4x, number times number, gives me 8. X times x gives me x squared. 2x times 5y, 2 times 5 gives me 10. And then x times y, I can't combine them, so it's just going to be xy. Next up, I'll multiply the 3y and times the 4x and the 3y times the 5y. So negative 3y times 4x gives me minus 12. xy or yx, it really doesn't matter. And then negative 3 times 5y, negative 3 times 5 gives me minus 15. Y times y will give me y squared. Notice we have xy, xy. We can combine them because they are the same thing. X times y, x times y. So we have 8x squared. 10xy minus 12xy gives me minus 2xy. Minus 15y squared. So this is an instance where I have two different variables. How am I supposed to know what simple standard form is? Again, we go alphabetically, so x comes before y. So every number that we have here that has the letter x gets written down first from highest exponent to lowest, and then we go to the y's. So x squared being the highest exponent of 2. Next up, we have 2xy. That has an x with an exponent of 1, so that would come after the x squared. After that, we have the standalone y squared. That has a high exponent, so that comes third. If I were to use the box method, I would write out a box. I got 2x minus 3y. And I got 4x plus 5y. I'm going to do the same thing. 4x times 2x gives me 8x squared. 4x times negative 3y, negative 12xy. I got 5y times 2x, so plus 10xy. And then 5y times negative 3y minus 15y squared. Because we have the xy in the middle here, we can combine them, and I'm going to end up with the 8x squared minus 2xy minus 15y squared. Now up above it said we have to pay attention to how it's written. Here we have 2x plus 3 squared. This does not mean 2x squared and then 3 squared. It really means I am multiplying 2x plus 3 2 times. So this is really 2x plus 3 times 2x plus 3. And from here I can use distribution or the box method to solve this expression. So using the box method, we got 2x plus 3, 2x plus 3, split it up, 2x times 2x, 4x squared, 2x times 3 gives me a positive 6x, 3 times 2x is a positive 6x, 3 times 3, positive 9. I have 6x and 6x in the middle here. So we got 4x squared plus 12x plus 9. Number 3 is that conjugate situation. So again, x plus 7 times x minus 7. We have the same thing in the same order with opposite signs. If I were to split it up into a box, one side will be x plus 7, the other will be x minus 7, and we'll split it up. We get x times x, x squared. X times 7 gives me a positive 7x. Negative 7 times x gives me a negative 7x. Negative 7 times 7 gives me a negative 49. Here in the middle, we have positive 7x and negative 7x. If I combine them, they actually cancel each other out. 7 minus 7 is 0, so they're going to cancel each other out. And I'm left with x squared minus 49. So that's the conjugate. So notice in this case, we can kind of do shorthand. X times x is going to give me the x squared. 7 times negative 7 is going to be the negative 49. I don't recommend doing that. I recommend doing the box method just to make sure, or using distribution in order to get the correct answer. Number 4, again, we have a plus 2 squared. This does not mean I square a and square 2 and I'm done. It means I'm multiplying a plus 2 twice. So a plus 2 times a plus 2. Now I can use the box method. Split it up, a plus 2, a plus 2. Split it up. A times a gives me a squared. A times 2 plus 2a. 2 times a plus 2a. And then 2 times 2 gives me a positive 4. I have like terms with 2a and 2a, so I end up with a squared plus 4a plus 4. Number 5, again, we end up with conjugate. 4x plus 3 times 4x minus 3. If I were to set this up with a box, one will be 4x plus 3. And the other will be 4x minus 3. Split them up. 4x times 4x is going to give me 16x squared. 4x times 3. 4 times 3 gives me a 12. X comes along for the ride. Negative 3 times 4 gives me a minus 12x. Negative 3 times 3 gives me a negative 9. 12x and 12x, like terms. Notice, though, that positive 12 minus 12, they're going to cancel each other out. So I'm left with 16x squared minus 9. Number 6, 3 plus d times 3 minus d. It's going to be the same thing. I'll use distribution on this. We have 3 times 3 gives me 9. 3 times negative d gives me minus 3d. D times 3 gives me a plus 3d. And then d times negative d gives me minus d squared. Notice here we have negative 3d and positive 3d that we can combine. They will actually cancel out. So I'm left with 9 minus d squared. And if we were to put it in simple standard form, again, higher exponent to lowest exponent means the d squared has to come first. I have to take the sign with take the sign with it. So negative d squared, no sign out front in 9, so that means plus 9. So either format here is the correct format. The bottom one is simple standard form. The other one is what you get after you combine like terms. And then we can do the same thing. So 7, I would use the box method. Same with 8 and 9. We can't use the box method because we got w on the outside here. So 7 and 8, I'm going to skip. I'll go to number 9. 9's a little bit different. We're going to use distribution first because we have a w outside the 2w plus 1. So I'm going to distribute the w first. W times 2w, 2w squared. And then w times 1, so plus w. So I took care of that. I now have 2w squared plus w, which is the result of distributing the w into that first set of parentheses. But I still have to multiply times 3w minus 2. And I can use the box method here to simplify. So box method means 2w squared plus w, 3w minus 2 off on the side here. 3w times 2w squared, 3 times 2 gives me 6. W times w squared is going to be w cubed. 3w times w, so plus 3w squared. Negative 2 times 2w squared is going to give me negative 4w squared. And negative 2 times w minus 2w. Do I have like terms? I see we have 3w squared and negative 4w squared. Because they are the same letter with the same exponent, I just have to combine them. So we got 6w cubed. 3 minus 4 gives me a minus w squared minus 2w. And that is the simplified expression on that one. And that is conjugates. Continuing practice multiplying different binomials, binomials times trinomials, monomials times binomials, etc. And also expanding out when I have a binomial raised to a power, like in number 4 and number 2.